Students will build a wire magnet motor. The motor demonstrates three changes in energy. 1. A battery to convert chemical to electrical energy. 2. An electromagnet to convert electrical energy to a magnetic field. And 3. The interaction between the electromagnet and a permanent magnet to generate motion resulting in mechanical energy that turns the axle. Each group of students will require the following materials to complete the investigation. 1. 10 centimeter by 10 centimeter piece of corrugated cardboard. 2. Small number 1 paper clips. 1 AA battery. 2 ceramic iron ferrite disc magnets, 1 inch by 5/32 inch, recommended. 125 centimeters of 26 gauge enamel coated magnet wire. 2 10 centimeter pieces of 22 gauge solid copper insulated wire, recommended 1 red or white and 1 black or blue. 1 piece of 2.5 centimeter by 5 centimeter coarse grit sandpaper. 1 30 centimeter ruler. 1 pair of scissors. 1 roll of electrical tape. And a stopwatch. The entire class will need at least one of the following items. 1 pair of wire strippers. 1 extra motor to be disassembled or motor diagram. Now we'll go through the procedural steps to complete this investigation. Step 1. Place the 2 magnets stacked on top of each other in the middle of the cardboard. Trace a circle around the magnets. Remove the magnets from the cardboard and set aside. Step 2. Bend open each paper clip 90 degrees at the U-shaped bend about halfway along the clip, forming a piece of metal with a long U flat on the table and a short upside-down U standing upright. Step 3. Bend close the upright short legs of both paper clips so that each forms a small closed loop at the top of the upside-down U. Step 4. Place each paper clip on top of the cardboard so the flat legs sit against the middle of the left and right edges of the cardboard, and the upright loops stand near the opposite edges of the traced circle. Secure the paper clips to the cardboard with 2 pieces of tape near the outside edges of the cardboard. Step 5. Take 1 piece of insulated wire and slide one of the exposed ends underneath one of the paper clips. Bend the end of the wire to ensure it is touching the paper clip. Use a piece of tape to secure the wire against the clip. Repeat this step with the other piece of wire by placing it under the other paper clip in the same manner. Both wires should be extending off the cardboard on the side closest to you. Step 6. Put the magnets back into the traced circle. Step 7. Leaving 12 centimeters of the wire free on both ends, wrap the enamel-coated magnet wire around the battery 20 to 30 times. Step 8. Slide the wire off the battery. On opposite sides of the coil, use the loose ends to wrap around the inside and outside of the coil 3 times, creating a tight ring. There should still be at least 3 to 4 centimeters of wire remaining, sticking straight out in opposite directions. Step 9. Use the sandpaper to remove the enamel coating on the top half of each end of the wire, from the tip to the ring. Step 10. Insert the wire circle into the paperclip loops so that the ring sits directly above the magnets. The ring needs to be as perfectly centered as possible. If it favors tilting to one side, that side is heavier, and the ends will need to be bent to better center the ring. The closer to center, the better the motor will work. Step 11. Tape 2 insulated wires to the ends of the AA battery. The wire ring should begin to spin due to the forces interacting. If it does not, give it a little push with your finger to help to get started. Some small adjustments, balancing the ring, moving the magnets, or adjusting the paper clips will likely be necessary to get the motor running. Step 12. Once the motor is running steadily, have one person in the group count the rotations of the motor while a second person times for 10 seconds. Do the best you can. Some motors may be moving quite quickly. Multiply your number of rotations in 10 seconds by 6 to get a number of rotations in 60 seconds. This is called rotations per minute, or RPMs. Repeat this 3 times and use the data to get an approximate average RPMs of your motor. Record the data on the student data sheet. As your students proceed through this investigation, have them consider and log their answers to the following reflection questions. After you completed the motor assembly, did you have to make any adjustments to get it to run or run better? If so, what adjustments did you make? What gave you the most challenge while building the motor? How did you overcome that challenge? What are some ideas of work you could potentially do with this motor if it were strong enough? Remove the battery and reconnect it facing the opposite direction. Get the motor spinning again. What did you notice about your motor's operation compared to the original observations? For complete information on Investigation 4, Fine Motor Skills, please refer to the Engineering Design